Now let's kick into gear with some technical topics, for it's now time for a session on operations and technology. We have two interesting talks which I recommend that you will not want to miss. The first talk is presented by Mr. Tashi Phuntsho, who is a network engineer and trainer at NSRC. The title of his talk is on securing internet routing, the puzzle pieces. So without further ado, Tashi, the stage is yours. Thank you very much.
Good afternoon, everyone. My name is Tashi. I'm a network engineer and a trainer at NSRC when I'm not doing my day job. This talk is about securing internet routing. There has been too much talk around securing internet routing, just too many puzzle pieces out there. It's too confusing for engineers on which piece to use for what purpose. So this is my attempt to demystify the many moving pieces when it comes to securing the internet routing. Acknowledgement, I have stolen slides, ideas from all these champions. So, all right, first, headlines. We never seem to get away from all these headlines. It's always there, just, sorry, I haven't updated the slides, but even on Saturday while we were taking a walk around the city, me and Dr. Philip, there was this massive route hijack that was happening from an unallocated AS number. Unallocated AS was hijacking routes that affected up to 89 ASNs. So why do these incidents keep happening? Maybe we go back to the basics of why these things keep happening. First off, internet, we all love the fact that it's decentralized, no one is in charge. But that also means when I look at my internet routing table, I don't have a reference point. I don't have a reference point to what is right on in the internet routing. The most important one, routing works by rumor. I say, hey, I am this network, here is my network. I expect my neighbor to pass it on to the rest of the neighbors being very honest and truthful. But somebody always wants to have fun in the middle. But we assume, so by the time somebody hears it at that end, it may not be, hi, I am Tashi from NSRC. It might be, I am Tashi from somewhere else by the time it reaches that side. So that's a big problem too. Routing works by rumor. And the worst of all, routing works in reverse. I tell you who I am, you tell me who you are, and then we exchange traffic, which means if I want to hijack someone's traffic, I just need to pretend to be that person and tell the internet, hey, I am that person. The traffic that was supposed to go there comes to me. So fundamentals of how internet routing works is what leads to all the problems that we have. And is it an easy fix? I don't think it's an easy fix. There's no flag day possible. We can't say there's a beautiful protocol, let's shut down the internet for 6 months, fix it and come back. And the best would be if every BGP update had an evil bit. Hey, I am bad, drop, right? Sadly, there is no evil bit. You cannot differentiate what's a good update and a bad update. Professor Steve Bellevin tried. He tried to write RFC 3514. Please read it if you're bored. He's saying, you bad people out there, please turn on the evil bit. Make it easy for me and my network to drop. But sadly, we don't have that. So what do we do? Since it's very difficult to identify what is bad, as you can see in everything that we do in security, what do? We try to attempt to identify what is good. And anything outside that, we assume it's bad and we try to drop it. Look at your TLS, look at your SSL, look at your DNSSEC. All these are attempts for us to try and identify something is good. Anything outside of that, we will say, it might be bad, let's drop it, right? So how do we identify good? Back to basics again. Can we use digital signatures? Yes, we can, right? Whoever has the private key can sign the authority, and then I publish my public key so that you can validate my authority to that resource. How do we adapt that to internet routing? Whoever is the holder of that resource, be it IPv4 resource, be it ASN resource, V6 resources, as long as I have the private key, I can authorize which network can originate that route on my behalf. So we're going back to basics. Problem with that kind of a structure is you need a chain of trust. Luckily, in the numbers world, unlike in the namespace, you don't have that many roots. In the namespace, you just have so many. So at least in the number space, you can follow the RIR delegation hierarchy. There are only 5 of them. You can follow that address allocation to build the chain of trust. Since this is not a workshop, I'll try to just skip it at the puzzle pieces level. So what do we do? If I am running a network, if I want to peer with someone, what do I do? First thing, before you peer with someone, you try and validate who they are. This is a network I used to run before, Bhutan Telecom. So if I want to peer with someone, I tell them, hey, I am Bhutan Telecom, here is my network. That someone should not blindly trust me. They should go and look up our authoritative database. In this case, you're looking up the APNX whois database, and you see that indeed this address space was delegated to me through the INET numob. You can also look at the AS objects and other bits. Once you have done that, do you manually craft filters? We covered those in the workshops over the last 4 days. We then start relying on what's called the Internet Routing Registry database. And it's a place where in the whois, I can't express my routing intent, but in the Internet Routing Registry, I can now go ahead and express my intent. I can say, hey, I own this address space, V4 or V6, and here is how I intend to route this out on the internet. Example, if you look at that route object, it kind of says, hey, me as the owner of this prefix, I am saying that I'll originate this prefix from this particular ASN, right? So that's what an Internet Routing Registry is supposed to do, publish my routing intent. And it's the other benefit of this is I don't have to manually craft filters. I can look up those objects in the IRR database, and then I can try and build filters with those. Here in this example, right-hand side, my right, your left, you can see I'm trying to build a prefix filter. Let's say my former network A17660 wants to peer with me. I'm using BIRD in this case. I'm using a BGP Q4 toolkit here, and I'm saying, please help craft a prefix filter so that I can peer with this network, and it throws me the prefix filters. It goes, looks up my route objects in the routing registry database, and it'll craft those filters for me. Top one being 4, below one I'm showing you the V6 one. But what if you try to peer with a network that is also a big transit provider? You will be accepting not just their address space, but also their downstream customers. So there is no way you can start crafting prefix filters line by line. So in that case, we look up what's called an aggregate proxy object called the AS set. In this example, AS-DRUGNet-transit is an AS set for Bhutan Telecom. It lists all the downstream customers of that network. So I can use that tool set not only to accept the prefixes from that network, but also all its downstreams. Beautiful. But problem with IRR is the way we craft these filters. The assumption is if the entry is there in the IRR database, it's valid. If the route is missing, I will not accept the route. So how do you interpret this? Just because me as an engineer, if I've forgotten to create an entry in the database, does this mean that my route doesn't exist in reality? So IRR has its own problems, right? The biggest problem being there is no single authority model. At least with the whois database, you can see that there are 5 RIRs, it's authoritative. But with the Internet Routing Registry database, there is no single authority. At last count, there was about 27 Internet Routing Registries out there, so which one do I trust? Right? And the biggest problem is that, the incomplete data set. Some engineers do not religiously update their entries in the Internet Routing Registry. Now, if I'm trying to use that to craft a filter, if you don't have an entry, I will never accept your route, right? So what does it mean? Just because you have not created an entry, does it mean your route is invalid? Right, so you have to factor in those things. And the most riskiest one is not every IRR is authoritative, which means anyone can go in and create any kind of object on your behalf. Somebody could take my address space, create a route object. Somebody could take my V6 address space, create a route 6 object without me knowing, right? That's why when you please refer to the IRR database to craft filters, make sure that you point to authoritative sources, right? Because the way it works is all the 5 RIRs, their WHOIS database also syncs to RADB example. So even if you look up RADB to craft your filters, please specify the source. Only accept entries that came from an authoritative source, right? In the old days, RTconfig, we used to use the small s as the source, pointed to APNIC, right? If I'm pairing with someone who is in the Asia Pacific region, even if I point to RADB, I might say I will only accept routes or objects that came from the APNIC WHOIS database, which is the authoritative source. Some recent improvements to the IRR. Our friend Aftab, he has been doing some good work there because this is a real problem. AS set, remember I said that many of us rely on AS sets to craft filters. Problem is, if you go with a non-hierarchical AS set, you have name collisions. Look at this, AS Amazon, which one is correct? Which one do I use to craft filters if I'm pairing with Amazon? So Aftab's proposal is a very good proposal where he's suggesting that no RIR should allow any non-hierarchical AS set to be created. It needs to be a meaningful hierarchical AS set. I've used my former network as an example of non-hierarchical, AS-DRUCnet-transit. Whereas if you look at the hierarchical AS set, you can see that it clearly says AS4826, which is Vocus, and its AS set name. So this is a hierarchical. So it can avoid this kind of generic name collisions that we find out there in the IRR database. Some recent changes to RADB finally. Since their migration to IRD version 4 last year, now the route objects or Route 6 objects or any IRR objects are being validated against ROAs, right? If you now try to create a route object in RADB or a Route 6 object, it actually goes look up the ROA, a corresponding ROA for that. And if it matches, then it'll allow you to create the entry, but if the max length does not match, or the prefix does not match, or the origin AS does not match, you can no more create those route objects or Route 6 objects in RADB. A very, very welcome change, but it took them too long also, I think, but never too late. It's a very good change that they have made. So, puzzle pieces, we looked at the WHOIS database, we looked at how to use the IRR database, and one more puzzle piece. When you do prefix filtering, you can now also filter it based on route origin ROAs out there, right? You receive routes, you compare that against ROAs. If they look valid, then you accept those routes. It's a straightforward, it's a very simple approach. You have this prefix, me as the owner of this prefix, I, as the owner of this prefix, can nominate any network and say, I authorize this network to originate this route on my behalf. Throughout the workshop, we have been talking, be careful with the max length. Initially, I think it was conceived as a multiplexing technique. Instead of me creating 1 million ROAs, they thought, okay, why trouble people? Let me give them a max length attribute. But now the max length attribute is what's getting exploited most of the time. Right? Don't go crazy with max length attribute. Please stick to what we call minimal ROAs when you create your ROAs. Yeah. And this is how route origin validation works. You, as the owner of your prefix, you digitally sign it, you nominate which ASNs can originate that on your behalf, you publish that to a repository, which is mostly your RIRs. And once that's published, next time whoever is doing route origin validation, they will pull all your digitally signed authorities, keep it in a validator. That validator will push a copy to your router, eBGP speaking router, and next time your eBGP speaking router receives BGP updates, you compare that against your validated ROA. Does the prefix match? Great. Does the origin AS match? Great. Is it within the max length? Great. Valid. If any of those doesn't match, not valid. But sometimes people don't even create ROAs, and that time we have unknown status. What do? You can't drop unknowns because you don't even know whether a ROA exists for that or not. That's route origin validation. Now, when it comes to RPKI or ROV, route origin validation, please be careful with how you use the max length attribute. I think in the workshops we discussed. If your aggregate is a /19, you might have a couple of sub-aggregates that you leak out. Maybe stick to a max length of maybe a /22, /21. Don't go all the way down to /24, because then you are now telling me, the back person, go ahead, leak out my more specifics, they will always look valid. I can hijack all your more specifics if you go with a crazy max length. So let's be very careful. In most of the cases, what we are finding is anyone who runs a multi-ASN network, as I used to run, I have my access ASN, I have my transit ASN within the same network. Many people only seem to create rowers on your transit ASN as the origin ASN, but where does your route originate from? Your route always originates from your access ASN. And when that route propagates, oh, wrong origin AS, because you have only created rower with your transit ASN, right? You have not created a corresponding rower with your access ASN. So please be careful, understand your network. Right? Let's move on. So we looked at rowers, we looked at route origin validation. The saddest part with route origin validation is you can only validate the origin. Is this AS allowed to originate that route or not? But it does not prevent, you can easily spoof that AS, you will look valid, right? So how do we make sure that people can't hit us with forged ASs? The whole idea, okay, you have done origin validation, now let's do a path validation. As I announce that route and as my route propagates across the internet, can I make sure that we can also validate that path? Beautiful idea called BGPsec. Still an idea. There's no known implementation out there. So hopefully this becomes a reality someday. The idea being you use the same RPKI framework, you use the same key pair that you have. One key is for your prefix that I showed you for rower. The other certificate is for your ASN. The idea being you will then start signing every eBGP speaking router in your network. You nominate them as you sign those eBGP speaking routers. And how does it work? It's what we call forward path signing. If I announce my route to my upstream, I sign that path and I say that I am announcing this to my upstream. You sign that to AS2. When my upstream, before they propagate it onwards to their neighbors, they sign on top of my signature. So you end up creating this chain of signatures, and at the receiving end, the receiver can first check my rower. Is the origin valid? Great. After that, it will validate each of the path signatures using the AS keys. Beautiful idea on paper, but the reality is very difficult. With route origin validation, all the crypto work is done by your validator. With BGPsec, the crypto work needs to be done on your router. We need to find a way to distribute keys of every eBGP speaking router globally. Right? You need to store them, and you need to validate every path. You need to verify the signatures. You need to do heavy crypto work. Right? Hence why BGPsec is still not a reality. Right? Can I have partial deployments? Maybe not. Can I jump if there is a router in the middle who can't do BGPsec? That's where my validation stops. Right? Complex crypto that we said. But there was also this talk by Randy Bush, what, 2 years ago on a podcast, where Randy feels if routers are allowed to generate their own key pairs, submit that to our RPKI repo for a signature. But let's see how that comes around. And the RFC actually lacks clarity around how do you distribute those keys, how do you manage those keys. So BGPsec, while it's a good RFC out there, we don't have any real-world implementations of that. The final piece of the puzzle of all the routing incidents that we see globally, 70 to 80% are just route leaks. Hijacks are not that common. Yes, we see hijacks, but majority of the routing incidents on a daily basis are route leaks. BGP by default seems to be a very permissive protocol. I'm configuring this link, it starts leaking out prefixes this way. right? And that's why we're having to come up with lots of patches. Like in the workshop over the last 4 days, we discussed RFC 8212, which is a very good new RFC, which says you will not accept any routes or announce any routes as long as if there is no explicit inbound or outbound filters, which is a very good tool to have. But how many vendors implement it? RFCs keep coming, but vendors, so my request is, please push your vendors. You are the one paying them, and maybe your next RFP should only list out those RFCs and say, I will only buy gears from you if you support this RFCs. Right? Else, people can keep writing RFCs, beautiful ideas, but if vendors don't implement, it's really not that useful. So route leaks happen a lot, and these are fundamental techniques that we have been using forever. If you run a network, you need to filter. Filter what you announce, make sure you know what you announce to your neighbor, and make sure before you accept any routes from your neighbors, you do some validation, either through some form of filters, right? Please apply max prefix limits. One of the biggest network incidents happened in Japan, 7 years ago or something, when Google started leaking out entity OCN's network. What happened to max prefix limit? Most of the incidents can be stopped if I apply some form of prefix limit on my peering session with my neighbors. I know you, I know your routes, I could give you double of that and say, okay, if you usually announce 10 routes, I'll say I'll give you up to 30 routes as the max prefix limit. Anything beyond that, if you're leaking the whole internet to me, at least that session goes down. Right, basic things, tools that existed for decades, we still don't seem to use it. Right? So how do we prevent these leaks? Sorry, I've adapted some from York Snyder's Nano talk. Peer lock light, I like this idea. The so-called tier ones, when you look up Wikipedia, are these networks. Will I ever be selling transit to NTT? Will I ever be selling transit to any of these networks? You certainly know sure that no, these people will not buy transit from you, right? Which means if I have a customer and if my customer keeps leaking any of those prefixes to me, I know that that's a leak, right? So you drop it. So peer lock light is a very good idea where you say that, hey, these are tier ones, they should never be buying transit from my customers for sure. So if I see their routes coming from my customer, it is a leak. Drop it, right? Peer lock, again, the same idea. In this case, A, B, C, D, and E, they are all entities. Peers, peer A has indicated that, hey, peer B is my allowed upstream, which means entity when it receives those. If they receive their routes from peer B, good. But if it starts receiving from C, D, and E, because of the peer lock feature, it'll say, no, you are not allowed to. But this is what I want to talk about, because Nan mentions BKNX will soon be updating this. This is a very good update that has come. It was what, 9234, RFC 9234? This is a very good one, BGP roles, to prevent route leaks, right? This is a new feature that has come in, and you negotiate that through your BGP update messages initially during the handshake process, role capability, right? And here you go like in the loose mode, you could say like, I try to negotiate. If my peer cannot do it, then we do traditional BGP, right? But in the strict mode, when we are negotiating, if you don't have that capability, I don't bring the session up at all, right? You have the choice on what to do. What roles can you have? You can be a provider, you could be a customer, you could be a peer, you could be a route server or RS client. Those are the most 5 common roles. And the only permitted relationships are those, right? Provider and customer, yep. If I'm a customer, can I have a relationship with the provider? Yes. If I'm a route server, who should I have relationship with? Only with route server, RS clients. If I'm a RS client, who should I have a relationship with? Only with the route server. But if I am a peer as a role, I should have relationship only with peer. Those could be your direct peerings that you do, right? Sadly, not available in any of the commercial BGP implementations. Bird does it, FRA does it, great. But does every network in the world use Bird and FRA? Right. So that's the sad part. RFCs come up, people have beautiful idea, but vendors never seem to catch up. So maybe my request, please chase your vendors and say, hey, when are you going to support this, right? So Beaconix, I think, is soon going to be implementing this, which is a good thing. So how does it work? I really like one more new attribute that has come. It's called only to the customer attribute, right? It's an optional, non-transitive attribute. Optional, not every BGP implementation may support it. Transitive, I don't leak it beyond my AS. Right. How does it work? How do you do validation when you learn a route inbound? If you receive a route that has the only to the customer attribute turned on, what does that mean? That route was only supposed to go to the customer, which means if you accidentally receive a route from your customer or your RS client as a route server, and if the OTC attribute is turned on, it is a leak. That route was only supposed to go to my customer. It was never supposed to go to others. You drop that. It prevents route leaks. Right? And when you are advertising that out, if I have a route and I mark it with that attribute only to the customer attribute, that means what? You can send it to your customer for sure, but you are not allowed to send it out to your providers or your peers or your route servers, because that route was marked as only to the customer, which means you again prevent leaks. Again, the sad part, no commercial vendors. Yeah, there is one out there, but it's not a full functionality. Microtext implementation is still not a full functionality, but we want the bigger vendors to be playing and helping out here. Right. So that was the BGP roles, new RFC to help prevent route leak. And the final piece of the puzzle is ASPA at this stage. Again, the idea being is provider authorization. Remember, we had ROA, route origin authorization. Similarly, me as a network provider or someone who runs a network, I nominate my upstream ASNs and call them the service provider ASN, and I sign that relationship. I say that I am AS17660, my upstream is 2914, and my upstream is, 6939. I put those two upstreams in what's called the service provider AS set, and I sign that relationship and I publish that, right? Like you publish ROA. This is what the object looks like. That's my ASN, those are my upstream providers, and for which address family is it? Is it for my V4 routes? Is it for my V6 routes? And I sign that object and I publish that, and we call it the ASPA object. It does not do what BGPsec does, but at least it provides me that hop validation with my upstream, and the upstream could have that next hop validated with their peers. So if we all do it, I think it can compensate for the lack of BGPsec on the internet. Is it real? Yes, it is. Does it work? Yes, but not on commercial boxes again, right? This was an open BGPD last year. I took it, when I saw that in the mailing list, I took screenshots. Look at this ASPA object that was published for this network. My network is AS945. Those are my nominated upstreams. I sign that, publish that. Somebody receives that route. Origin AS is me, great, because that was my network. But the next hop is 61138, not in the list of my upstream ASNs. And that is ASPA invalid. There is a new status which says path not valid. Right? Timeline. Last year was a lot of talk. I was talking to Tom Harrison, Apinix routing regist. He's the product manager for RPKI. He had released a demo, a signer demo, but I think 2024, we should be seeing a lot of action this year. And hopefully by next year, all the RIRs allow us to create ASPA objects. And hopefully soon, the commercial vendors will allow us to do ASPA validation. Right. If you want to learn more about this, please head over to NSRC's learn.nsrc.org. There are lots of video recordings, lots of slides out there. Right? And finally, to wrap up, few more slides. What do we do? All this analysis, how did people do? How did people manage to go back in time and analyze a route hijack? because you don't see that on your router. That's where most of us, me growing up as a network engineer in Bhutan, I relied mostly on route views. When I announce a route, how does my route propagate on the internet? So I look up at route views, different global instances. Oh, in North America, my route, yeah, looking good. Go to South America, looking good. So wherever route views had presence, I look up those collectors and see how my routes propagate. Sometimes when I troubleshoot things, I need to go back in time to understand what the problem was. Then I look at route views archive data. So it's a very, very important tool, right? Route views started off in 1995, right, at the University of Oregon's Advanced Network Technology Center. And the biggest thing here is the data archives. Every 2 hours, it archives the BGP data. It's an MRT dump. And as of September last year, 50 terabytes worth of compressed historical data, 27 years worth of BGP data, right? Quickly going, I think now we have 45 collectors. There's one in Beaconix. And if you want to pair with route views, please go to this link. Do send full table if you want to. Do not send default routes. Remove your null routes. Do not send your private addresses. Don't try to tell route views, here is my alternate path. It's a collector. It does no forwarding. There's no data plane. It's just a collector, right? And when peering with multi-hop collectors, be very careful. If you don't want to directly peer at an exchange, you want to peer multi-hop, understand the default behaviors of BGP. Thank you so much, everyone.
Thank you very much, Tashi, for a very detailed talk on what we can do to overcome these challenges in securing routing. For our second talk on operations and technology, I would like to once again welcome to the stage Jose Santiago from Guam Exchange, who will share with us a story on the implementation of the MANRS system at the University of Guam. Please join me in welcoming Jose to the stage once again.
Hi for everybody. So that might have been a little bit of a confusing introduction. So I no longer work at the University of Guam. So I work now at an Internet Exchange Point data center called Guam Exchange, but I did work at the university for close to 12 years. And I never got to share this story, so I'm going to share this from my experience, from myself, well, what we went through of implementing MANRS at the university. We're going to take this as kind of like a template that you can take of my experience and implement it in your network, because even if the university is an academic institution, under the MANRS program, it is seen as a kind of enterprise network program, and I'll explain that as we go on. Okay. So just a brief history for those who haven't heard of MANRS. MANRS was published in 2014, but it had discussions about this whole kind of idea of what it meant to be having a secure network in 2011 at the ISOC and IETF meetings. It was originally called the Routing Resilience Manifesto, not exactly as rolls off the tongue as MANRS does, and it's a kind of a I guess a pun for having good network manners, right? Throughout the slide, I'll have these links on the bottom right that shows where you can go to find out more information on how I got this information. So if you want to deep dive more into what each of these slides are or what they're saying, you can look at that. Okay, so this is the MANRS objective. What was the point and what was the purpose of MANRS coming together in the first place? There's these 4 objectives. It is to raise awareness, to promote, to demonstrate, and to provide a framework. As you can see, it's not exactly all a technical thing. It's not focused on a technical tool and how to have the most secure network. It's not saying get a firewall and have a safe network. No, it's all about best practices and following industry standards to make sure that you are behaving how you're supposed to behave in the network, or so to speak, having the best manners on the network, right? Being a good network citizen and a netizen is some of the other puns that will be coming out of these things. All right, so again, my experience working at the university for over 12 years, but I only started working in the networking field about 2016, and I started learning about best common practices and RFCs from workshops and logs like the one we held last week, throughout the week. Going to these lectures and just learning from industry leaders about what is best common practices. So, and then through these workshops, I learned about MANRS in 2018. So 2 years after I got into networking, that's when I first learned about MANRS. And then 5 years later, we completed the application in 2023. Now, normally, a MANRS implementation shouldn't take 5 years, but the University of Guam had a kind of unique situation in that Guam is a US territory in an Asia-Pacific region. So originally, when we got our network space, we were under ARIN, and the university being a a leading institution in the island got its network legacy address space from ARIN, and I'll go through that later, and how and why it took until 2023 to finally achieve MANRS compliance at the university. All right, so as I mentioned, there are 4 different programs. The university falls under the Network Operators program, but there are others. You can join the IXP program, the CDN cloud providers, and the equipment vendors. Rest assured, as soon as our network gets running at Guam Exchange, I'm going to go after that Join IXP program and get Guam Exchange or Guam IX as a MANRS compliant IX, right? All right, so the MANRS scope, what are the main problems or main issues that MANRS is trying to resolve? It's trying to resolve the incorrect routing information, traffic spoofed source addresses, and coordination and collaboration between networks. Because I guess IT people tend to be a bit shy and don't really talk to each other as much. So this is trying to help promote the whole collaboration aspect. That it's not just, here's my network, that's it. We need to continue to build, establish a relationship so that whenever there's a problem, we can continue to talk to each other and like, hey, there's something wrong on this network or something doesn't look right. Can you take a look, rather than going through a whole help desk entry. And it's a lot easier if you know that person that you've been sharing a beer with for the past how many years, and you can call them up and say, hey buddy, can you help me with this? Yeah. All right, so these are the actions for our network operations program under the MANRS program on how to achieve MANRS compliancy. These are kind of like the checklist that we go through. So it's filtering, anti-spoofing, coordination, and global information. And I'll kind of deep dive a little bit of what each one is, and then what the university did to accomplish that. So the first action is filtering. So in filtering, what you want to do is prevent propagation of incorrect routing information, make sure that you're not accidentally leaking information that's not meant to be leaked. As Tashi was saying, BGP is a pretty leaky protocol. And then making sure you have your own defenses in place, you have filters in place before you start establishing your peering. And when you're setting up an EBG session, if a full table is required, at least block the bogons, right? If you're not just accepting the default and you're accepting the full table, making sure that you're aware that there are some prefixes that are not meant to be there, right? And so we did just that. Follow the exact checklist. We did that. We just configured our route filters. Here's some example of a route filter that we did on Juniper. So the university has a MX204 as its border router. Here's an example I did in V6. It's really simple, right? So that's our IPv6 address, and that's all we'll announce. We won't announce anything else. All right, action 2, anti-spoofing. So implementing BCP38, the URPF protocol, it denies outbound traffic from customers which has spoofed address space. We went through this in the workshop this past couple of days. It was very exciting to see how students were able to handle URPF configurations in their lab. And it's a very simple thing. All you have to do is make sure that you implement this configuration on any interface going to your customers. For the university, our customers are our own staffs, our own buildings, our own students, and so all we have to do is implement URPF on each VLAN interface going to each different subnet that we assign to all the students or all to the different colleges and buildings, right? And to test and verify that we have URPF running and that we are not, there's no spoofing, or if anywhere we're to try and spoof that it's blocked, we ran this program from the CADA spoofing test program. And that's the link to go and download it. You can run it today, see if the hotel is able to be spoofed. That'd be fun, right? Anyways, I found that it was easier to run on a Mac laptop rather than a Windows for some reason. We tried a couple times, but we ended up just running it on a Mac. I'm sure you can get it to run on Windows, but for some reason, it was just having some weird driver port issues. So that was just my experience. I'm sure it's workable though. Okay. This is an example output from the KDA spoof thing. So we ran it on the one of our VLANs. So you can see the client address down there, and then the IPv6. We got 8 block check marks, means good to go. So for the MANRS compliance, all you gotta do is take a screenshot, save the results URL that you get after running this program, add it as part of your application. Right? Action number 3 is coordination. So, like as I was saying, it's not all just a technical thing. Networking is as much social networking as it is technical networking. You've got to know the people that you're working with. That's what's great about like these peering forums and getting together and having these peering personals, so that when you peer with people, you remember like, hey, that's that guy that almost tripped on the stage. So, you make these social connections so that when you guys are dealing with problems, it's not such a hard thing to deal with. Having a social community where everyone's helping each other. I mean, what was it, BBIX's slogan? No peering, no internet. That's the same thing. No social peering, no social network, nothing happens. If we don't talk to each other, we don't exchange information, things get very hard to deal with, right? And so that's what this kind of talks about. One way you can accomplish that is just by making sure that all of your information is up to date. Making sure that your phone numbers, your social medias, your website links, all of it is up to date. You go to PeeringDB, your RIRs, make sure all of that information is up to date. As Tashi was mentioning in his presentation, is if you don't keep your information up to date and people try to use that information to implement these filters or these rules, it's gonna not work, right? So it's just the trained habit that you make sure your information's up to date. And you can use free tools like the bgphe.net or a CLI Whois to find out information to make sure what your information is good. So that's what our PeeringDB entry looks like. You get an email to contact, a phone number to call, and then if you want to use APIs and create scripts to pull information, here's our Whois information, right? Right? And the last one, global information. Tashi just spent an entire slide talking about ROAs, and that's pretty much it. It's just making sure that what you advertise is yours and it's signed, and that it gives a way other people to verify. It's not, you don't have to take my word for it. I've had this prefix notarized by a higher authority, and we can trust it. If the community has a central point of trust, then we can be sure that the information that they're receiving is good to go, right? So back to that story of what I was talking about, why it took the university 5 years to join MANRS. It wasn't until about August 2023, you can read the whole story about here. The university had a legacy ARIN address space, and it was a difficult situation for universities, not just Guam, but any US territory US institution, university that had legacy space to sign these ROAs. So until they fixed that situation, we were able to that's when we were able to sign it and finally go for MANRS compliance, right? So once we signed our ROAs, you can see like when we go to route views, you look up our address space or prefix, we have a state valid. You go to a free website tool like Hurricane Electric's BGP tool, we have that little green check mark and a green key, shows that you're valid. So there's all these free things that you can do to check and make sure that stuff, all right? And then after we signed our ROAs, we also implement so that our stuff is signed and so that people, when they check on it, it's good. But we also implemented RPKI ROVs to make sure that when people send us their information, that we can check that it's good. These are the route origin validators that we deployed. We have 2 kind of in tandems, just in case one has any bugs or issues. We have RPK client plus the RTR, and then we have a route runner 3000 from Nlet Labs. Okay, that's what we used, and it runs great. Right, so here's the story. So in November of 2023, the NSRC came to Guam to teach a workshop, and they held a DEA with us, kind of walked us through the issues, and walk us through the configurations. We reviewed all of the steps that we did. It was just one Saturday morning. Dr. Philip Smith came over. We had all our team on the table just talking about it. And then on November 4, we applied for MANRS. And 2 days later, we got it. So it's not hard. Technically, you know, if it wasn't for that iron thing, I think we would have done it in like less than a week. Because it's really, I mean, it's 2 technical pieces and just 2 kind of social pieces, right? So yeah, 2 days later, we got our network compliance thing. We got a little check mark saying good, 100% coordination, good, 100%. And then the last part is, as MANRS is a social thing, we promote it, right? Again, I joined networking in 2016. I didn't learn it about 2018. So that means we as a community need to do a bigger job of communicating and talking about it and promoting all of these things. It doesn't cost anything, but it costs a lot if you don't do it, right? So yeah, we put a website, we got it and posted on Twitter, and then you get to have that little badge on your website saying that you're a MANRS compliant organization. You can, I mean, you could use it as leverage, maybe saying when you go up for a proposal, like I'm only gonna buy transit from an ISP that's MANRS compliant. You know, there could be a time when that comes to that. Right, so these are just some additional resources of how to implement MANRS in your network. There's a ton of resources out there. These are just the ones that we used. All right, and that's pretty much my presentation on how we deployed MANRS at the University of Guam. And I hope you guys can deploy MANRS in your organizations as well and help make the world a better place. Thank you.
Thank you very much. Thank you very much, Jose, and please remain on the stage or in the area a little while longer. May I invite Tashi to rejoin us on the stage, please? Thank you very much, both of you, for a very, very valuable session on operations and technology. And may I now invite Professor Kanjana Sud, Vice Chairman of the TH-NIC Foundation, to present a token of appreciation to both our speakers in this session. Thank you very much, everyone. So let's take another break for 30 minutes to recharge on some coffee and snacks, and perhaps to continue to network a little bit more, as Jose was saying. And please return to this room at 4:40 p.m. for our panel discussion on Internet News Space. So see you all at 4:40 p.m. Thank you very much.